All right, we're going to do a couple of harder problems here on page 620. I'm going to start with number 5. We're going to figure out the surface area of this pyramid here. They actually asked for lateral area, but I'm going to do the surface area as well. Um, Number 5 here. And we kind of drew the net already, but what we got to figure out right at the get-go, and hopefully you can see it inside this picture, there is a right triangle right here. And we have to figure out this blue line, the slant height, L. Okay, I redrew that triangle down here, and here would be the blue line. And we're going to do a little a squared, b squared, c squared. A squared, phi radical 3 squared is equal to the slant height squared. Now, of course, this is going to be difficult. Understand that this 2 means split it up the same number of times itself. 5 times 5 is 25. 3 times 3 on the inside is quarter root of 9, which is 3. 25 times 3 is 75. And I took the liberty and took the square root of 139 to be 11.8. So once I draw the net, each one from the highest point straight down to the base, from the highest point straight down to the base, this here is 11.8, the slant height. When you open up the net, it's also basically the height of each one of these little baby triangles, and there's 6 of them because this is a hexagonal base. So I'm going to try to figure out the area of a triangle here. Area of the triangle. Shoot, my thing's not working. It is 1/2 base. The base is 10, 10, 10 times the slant height in blue, 11.8. And of course, there are 6 of them, so we're going to multiply by 6 because there are 6 triangles. And we're going to also figure out the area of the hexagon. And that, of course, is 1/2 apothem. They give us the apothem of 5 radical 3. And then multiply it by the perimeter. 10 plus 10 plus 10 plus 10, 10 times 6 sides. And then we'll figure out what these guys are and figure out the surface area. Okay, so I did all the calculations in advance here. So all 6 triangles, 1, 2, 3, 4, 5, 6, has an area of 354. Of course, that would be base times slant height divided by 2. This is also the lateral area, which I think the direction's all they wanted. But we also figured out the area of the hexagon here, 259. So together, the entire surface area is 613.8. Moving on to number 11, they're going to ask us to figure out the lateral area of the cones. I'll probably figure out the entire surface area, but if I look at this picture carefully, this 26, because they drew the entire diameter, I'm going to assume that they meant this entire diameter is 26, which of course would mean half of it is the radius, half of 26 is 13. So I'm going to go with, although I'm not 100% positive, I'm going with that is 13. This inside here is the regular height. And when we try to figure out surface area or lateral area, we don't need the inside height. We need, and I'll highlight this in red, we need this lateral area, not lateral area, slant height right there, which in this picture is right here. And hopefully you can see this basic a squared, b squared, c squared triangle. So I did 13 squared plus 22 squared is equal to slant height L squared. Go ahead and took the liberties and figured out what the slant height is. It's 22.5. So when I open up this from a 3-dimensional picture, it goes from the highest point to the base. Now you would think, well, because it's on the slant, it would be right here. Well, it kind of doesn't matter, but technically that's not where it is. It is from here straight down 90 degrees. That's the slant height L, which we just figured out to be 25.55. Okay? Now, I believe they just want the surface area, the lateral area, but I'm going to figure out the surface area here, which includes both the circle, pi radius squared, and then the area of the triangle. Of course, when you open this guy up, it's a triangle. This portion here is the circumference. So it is 1/2 circumference, 2 pi r, radius is 13, times, again, the red slant height, 25.55. And going to my calculator, the area of the circle is 530.66, and the area of the triangle is going to be 1,042.95. If they just want the lateral area, that would be the triangle only. That would be LA, the lateral area. But I like the surface area, so I'm going to add this circle plus the triangle, and the surface area is 1,573. Okay, we're going to look at number 18 here. We're going to try to figure out the surface area of this figure. This is a hexagonal pyramid. I drew the net already. I had to add this 8 centimeter because my paper was blocking it. Basically, you've got the slant height already on the triangle. You've got this base of 8. You've got a height of 13. So it'll be easy to figure out the area of the triangle. It's all about the area of the hexagon that's going to be the problem. Hopefully you recall the area formula for a hexagon is 1/2 apothem times perimeter. So I kind of redrew the hexagon there. The perimeter is going to be no problem because it's 8, 8, 8, 8, 6 times. What we're going to need, though, is angle measurements, and then we're going to use trig to figure out that red apothem. 360 divided by 6. Hopefully you recall this. This is 60, 60, 60, 60, and then that 60 gets crushed into a 30, 90, 60 degree triangle here, and I'm highlighting this triangle down here, right here, just kind of enlarged it. And I need to figure out that apothem, and I can use basic trig. I'll stand at 30 degrees. Opposite the 30 is 4. This is adjacent, so we got tangent of 30 degrees is opposite over adjacent. And poof, I went to my calculator. The apothem is 6.9. So the area of the hexagon is 1/2 apothem times perimeter. The perimeter is 8 times 6 because obviously there are 6 sides. And if I'm cheating here, the area of the hexagon with the calculator is 166.3. Let's go figure out the area of a triangle here. The area of one of these triangles is 1/2 base 8 times slant height of 13. That area is going to be 52. How many triangles do we have? We have 1, 2, 3, 4, 5, 6. So we're going to multiply that by 6 triangles. And that result, triangles, the area of all the triangles is going to be 312. If I want the entire surface area, I know this is a total mess. 6 triangles, 1 hexagon. If I add those two together, you will get 478.3. And this is in centimeters squared. This is number 18. Figure out the hexagon again, and that will be the key, using the trig button.